Mars, a cold, desolate world, known for its rusty red surface and thin, unbreathable air. But what if that barren landscape could one day become a thriving, Earth-like haven? What if the technology exists to transform Mars into a place where humans could live, breathe, and build a new civilization? This isn't the plot of a sci-fi movie. It's a real scientific possibility, and it's called terraforming. Today, we're diving into the incredible science behind turning Mars into a second Earth. We'll explore how we might melt ice caps, thicken the atmosphere, and even create breathable air. But it's not just about the how, it's about the why. What would it mean for humanity to reshape an entire planet, and what challenges, both technical and ethical, stand in our way? Strap in, because by the end of this video, you'll see Mars in a whole new light, and maybe even imagine yourself walking on its transformed surface. Let's get started. Terraforming. It's a word that sounds like it belongs in a science fiction novel, but it's actually a very real concept scientists are exploring today. At its core, terraforming is about reshaping an alien world to mimic the conditions of Earth. For Mars, that means tackling some pretty daunting challenges. Right now, the red planet is a freezing, dusty desert with an atmosphere so thin it's practically a vacuum. The air is mostly carbon dioxide, there's no liquid water on the surface, and the planet is bombarded by harmful solar radiation. Turning Mars into a place where humans could live without spacesuits sounds like a monumental task, and it is. But here's the fascinating part: we already have some ideas about how it could be done. One of the biggest hurdles is Mars's frigid temperatures. On average, the planet sits at around -80 degrees Fahrenheit, which is far too cold for liquid water, or life as we know it. To warm things up, scientists have proposed releasing greenhouse gases into the atmosphere. These gases, like methane or carbon dioxide, would trap heat from the sun, gradually raising the planet's temperature. It's a bit like how Earth's own greenhouse effect works, but on a much larger scale. The catch: we'd need to find a way to produce and release these gases in massive quantities, which is no small feat. Another major challenge is Mars's lack of a magnetic field. Unlike Earth, which has a protective magnetic shield that deflects harmful solar radiation, Mars is exposed to the full force of the sun's rays. Without a solution, this radiation would make long-term human settlement nearly impossible. One proposal is to create an artificial magnetic field, perhaps by positioning a powerful magnet at a specific point between Mars and the sun. This could act as a shield, allowing the atmosphere to thicken over time and making the surface safer for life. And then there's the issue of oxygen. Even if we could warm Mars and protect it from radiation, humans still couldn't breathe the air. That's where microorganisms come in. Scientists have explored the idea of introducing specially engineered microbes to the planet. These tiny organisms could break down carbon dioxide and release oxygen, slowly transforming the atmosphere into something breathable. It's a process that would take centuries, but it's a crucial step toward making Mars habitable. So, is terraforming Mars possible? The short answer is maybe. The science is there, but the technology and resources required are staggering. We'd need to develop advanced tools for producing and managing greenhouse gases, create systems for generating artificial magnetic fields, and engineer microbes capable of surviving and thriving in Martian conditions. It's a project that would span generations, but the potential payoff, a second home for humanity, could be worth the effort. What's clear is that terraforming isn't just about changing a planet. It's about pushing the boundaries of what we think is possible. Mars and Earth might seem like distant cousins in the solar system, but the differences between them are far greater than the similarities. Right now, Mars is a frozen desert with an atmosphere so thin it barely qualifies as just 1% of Earth's atmospheric pressure. To put that into perspective, if you were to stand on the surface of Mars without a spacesuit, the lack of pressure would cause your blood to boil almost instantly. And if that weren't enough, temperatures on Mars regularly plummet to a bone-chilling -80 degrees Fahrenheit, making even the coldest places on Earth seem mild by comparison. But perhaps the most critical difference is what Mars doesn't have: a magnetic field. On Earth, our planet's magnetic shield protects us from the relentless barrage of solar radiation and cosmic rays. Mars, however, lost its magnetic field billions of years ago, leaving its surface exposed and lifeless. Without this protective barrier, any attempt to make Mars habitable would require shielding it from these harmful radiations, which could otherwise make long-term survival impossible. So, what would it take to transform Mars into a world that could support life? First, we'd need to thicken its atmosphere, creating enough pressure to sustain liquid water and breathable air. Next, we'd have to find a way to warm the planet, raising temperatures to levels where life as we know it could thrive. And finally, we'd need to figure out how to protect Mars from the constant bombardment of radiation, either by recreating a magnetic field or finding another solution. These are monumental challenges, but understanding the stark differences between Mars and Earth is the first step toward bridging the gap between a barren world and one that could one day feel like home. To turn Mars into a second Earth, the first challenge we'd face is making it warmer. Right now, the average temperature on Mars hovers around a bone-chilling -80 degrees Fahrenheit. That's far too cold for liquid water or life as we know it to exist. But what if we could change that? Scientists believe the key lies in something called the greenhouse effect. You might recognize this term from discussions about climate change on Earth, but here's the twist: on Mars, we'd actually want to amplify it. The idea is to pump greenhouse gases like carbon dioxide or methane into the Martian atmosphere. These gases would act like a giant thermal blanket, trapping heat from the sun and gradually warming the planet. One potential source of these gases is Mars' own polar ice caps, which are packed with frozen carbon dioxide. By strategically releasing this CO2, we could kickstart the warming process. Another option: importing gases from elsewhere in the solar system, like mining methane from Saturn's moon Titan. But no matter where the gases come from, the scale of this operation would be staggering. We're talking about centuries of effort and energy consumption on an almost unimaginable level. Now, here's where things get tricky. Even if we could release enough greenhouse gases, could we speed up the process? Some proposals suggest using orbital mirrors to focus sunlight onto the Martian surface, or even detonating nuclear devices to vaporize the ice caps faster. Sounds like science fiction, right? But the risks are very real. Altering Mars' climate on such a massive scale could have unintended consequences. What if we trigger runaway warming, making the planet too hot? Or worse, what if we destabilize its atmosphere entirely? These are the kinds of questions scientists are grappling with as they explore the possibilities and the limits of terraforming. So, while warming up Mars might seem like a straightforward first step, it's anything but simple. It's a delicate balancing act between ambition and caution, requiring not just technological breakthroughs, but a deep understanding of how planetary systems work. And even if we succeed, this would only be the beginning of a much longer journey. So, we've talked about the challenges of heating up Mars, but what about its atmosphere? Right now, Mars has an incredibly thin atmosphere, about 1% the density of Earth's. That's not just a minor inconvenience, it's a deal-breaker for life as we know it. Without a thicker atmosphere, liquid water can't exist on the surface, and humans would need pressurized suits just to survive. So, how do we go from this barren, airless landscape to something that could support life? The first step would be to increase the atmospheric pressure. on Earth, our atmosphere is a delicate balance of gases that keeps temperatures stable and allows water to flow freely. To replicate that on Mars, we'd need to pump up the pressure significantly. One idea is to release gases trapped in the planet's soil and polar ice caps. Mars has a lot of carbon dioxide frozen at its poles, and if we could release that, it might help thicken the atmosphere, but even that might not be enough. Another option is to bring gases from elsewhere like comets and asteroids. These space rocks are rich in volatile compounds like ammonia and methane, which could be harvested and transported to Mars. Imagine redirecting a comet into the Martian atmosphere, where it would release gases as it breaks apart. It sounds like science fiction, but it's a concept that scientists have seriously considered. Of course, the logistics of moving comets or asteroids across the solar system are mind-boggling, and the risks of such an operation are enormous. But even if we could pull it off, there's another problem: keeping the atmosphere stable. Mars doesn't have a strong magnetic field like Earth's, which means its atmosphere is constantly being stripped away by solar wind. Over time, any gases we add could simply drift off into space. So we'd need to find a way to protect the new atmosphere, perhaps by creating an artificial magnetic field or finding another way to shield the planet. The truth is, creating a thicker atmosphere on Mars is one of the most daunting challenges of terraforming. It's not just about adding gases, it's about understanding the planet's geology, chemistry, and even its place in the solar system. We're talking about a process that would take centuries, if not longer, and require technologies that don't even exist yet. But for those who dream of a habitable Mars, it's a challenge worth tackling. After all, the reward, a second home for humanity, could be the greatest achievement in our species' history. So we've warmed Mars and given it a thicker atmosphere. What's next? Well, humans can't survive without oxygen, and that's where things get tricky. Even if we manage to create a breathable atmosphere, we'd need a way to keep the oxygen flowing. One of the most fascinating ideas revolves around harnessing the power of nature itself using photosynthetic organisms like algae or bacteria. These tiny life forms could take in carbon dioxide from the Martian atmosphere and release oxygen, just like plants do on Earth. It's an elegant solution, but it's not without its hurdles. Mars's environment is still incredibly harsh: low temperatures, high radiation, and limited resources. Could these organisms adapt and thrive, or would they need constant protection and maintenance? Another approach takes a more technological route. Instead of relying on biology, we could use machines to extract oxygen directly from Martian soil or water. Scientists have already demonstrated this on a small scale with tools like MOXIE, a device aboard NASA's Perseverance rover that converts carbon dioxide into oxygen. The challenge here is scaling up, building enough machines to produce oxygen for an entire population, not just a rover, and let's not forget the energy requirements. Would we need to set up massive solar farms or even nuclear reactors to power these systems? Both methods have their pros and cons, but the real question is whether we can create a self-sustaining oxygen cycle on Mars. Imagine a future where the oxygen we breathe is constantly replenished by a combination of biological and technological systems. It's not just about survival, it's about creating a stable, long-term environment where humans can thrive. But how long would this take? Decades, centuries? The timeline depends on how quickly we can overcome the technical and environmental challenges. And here's something to think about: what if we combine both approaches? Could a hybrid system, blending biology and technology, be the key to making Mars truly Earth-like? The possibilities are endless and the stakes couldn't be higher. After all, oxygen isn't just a resource, it's the breath of life itself. Now, let's tackle one of the most critical challenges in making Mars habitable: shielding it from radiation. Unlike Earth, Mars doesn't have a strong magnetic field to deflect the constant barrage of solar and cosmic rays. This means anyone living on the surface would be exposed to dangerous levels of radiation, which could lead to serious health risks over time. So, how do we solve this? One of the most ambitious ideas is to create an artificial magnetic field for Mars. Picture this: a network of superconducting loops placed strategically around the planet, generating a protective shield that mimics Earth's natural defense. While it sounds like something out of a science fiction novel, researchers have already begun exploring the feasibility of this concept. The catch, building and maintaining such a system would require staggering amounts of energy and resources, not to mention advanced technology we're still developing. Another approach is to think smaller and closer to home, literally. Instead of shielding the entire planet, we could focus on protecting human habitats. Building underground colonies is one promising option. By digging beneath the Martian surface, we could use the planet's own soil and rock as a natural barrier against radiation. It's a practical solution that doesn't require reinventing physics, but it does come with its own set of challenges, like ensuring these habitats are livable and sustainable over the long term. Then there's the idea of using materials with unique properties to create localized shields. For example, superconducting materials could be used to generate small-scale magnetic fields around specific areas, like greenhouses or living quarters. These materials can carry electric currents with almost no resistance, making them incredibly efficient. But again, the technology is still in its infancy, and scaling it up to protect entire cities or regions would be a monumental task. The big question is, how realistic are these ideas? While each proposal has its merits, they all face significant hurdles. Creating an artificial magnetic field would require breakthroughs in energy production and material science. Underground habitats, while more feasible, would need extensive infrastructure and could limit our ability to explore and utilize the Martian surface. And localized shielding with superconducting materials, that's still largely theoretical. The truth is, we're not quite ready to implement any of these solutions on a planetary scale, but that doesn't mean we won't be in the future. With continued research and innovation, what seems impossible today could become achievable tomorrow. So, what do you think? Would you feel safer living underground, or would you prefer to see Mars enveloped in a giant magnetic shield? Each option has its trade-offs, but one thing's for sure: solving the radiation problem is a crucial step toward turning Mars into a second home for humanity. Now, let's talk about one of the most critical steps in transforming Mars into a habitable world: introducing water. Water is the foundation of life as we know it, and without it, any hopes of creating a thriving ecosystem on Mars would be impossible. Fortunately, Mars isn't entirely dry. It's actually home to vast reserves of water, but it's locked away in the form of ice. The challenge: figuring out how to unlock this frozen resource and create a stable, self-sustaining water cycle. One idea involves using massive orbital mirrors to focus sunlight onto the Martian poles, where much of this ice is concentrated. By directing concentrated solar energy, we could gradually melt the ice, releasing water vapor into the atmosphere. Another approach might involve drilling into the ice deposits and using heat or other technologies to vaporize the water, allowing it to circulate and condense as rain or snow. Both methods have potential, but they come with significant challenges. For example, Mars's thin atmosphere makes it difficult to retain water vapor, and the planet's freezing temperatures could cause any liquid water to quickly turn back into ice. To create a sustainable water cycle, we'd need to carefully manage the release and distribution of water. One possibility is seeding the atmosphere with greenhouse gases to raise temperatures, helping to keep water in its liquid form. Additionally, we'd need to ensure that water doesn't simply evaporate into space. a problem Mars has faced for billions of years. This might involve creating protective barriers or using engineered materials to trap moisture in the atmosphere and on the surface. But what about the long term? How do we ensure that a future Martian civilization has a reliable water supply? One solution could be to create underground reservoirs, storing melted ice in protected environments where it's less likely to freeze or escape. We might also explore technologies like atmospheric water harvesters, which could extract moisture from the air and recycle it for human use. These systems would need to be incredibly efficient, as every drop of water on Mars would be precious. Ultimately, introducing water to Mars isn't just about melting ice, it's about creating a delicate balance. We'd need to carefully control temperature, pressure, and distribution to mimic Earth's natural water cycle. It's a daunting task, but one that could pave the way for a thriving, life-sustaining environment on the Red Planet. The question is, are we ready to take on such a monumental challenge? And if so, what other innovations might we need to make this vision a reality? Imagine stepping onto the surface of Mars, ready to plant the first seeds of a new world. But before we can even think about growing crops, there's a major hurdle to overcome: the soil. Martian soil isn't just barren, it's downright toxic, packed with perchlorates, chemicals that are harmful to most Earth plants, and lacking the organic matter that makes soil fertile. Mars presents a unique challenge for agriculture. So, how do we transform this alien ground into something capable of supporting life? The first step is detoxification. Perchlorates, while dangerous, aren't indestructible. Scientists have proposed using bacteria or fungi that can break these chemicals down into harmless compounds. Think of it as nature's cleanup crew, but engineered for an extraterrestrial environment. These microorganisms could be introduced to the soil, where they'd work over time to neutralize the toxins. It's a slow process, but one that could lay the groundwork for life-sustaining soil. Next, we'd need to address the lack of organic matter, the very thing that gives Earth's soil its richness. One solution might be to import compost or other organic materials from Earth, kickstarting the process of soil enrichment. Alternatively, we could explore the potential of recycling human waste or cultivating algae to produce organic matter on Mars itself. Over time, as plants grow and decompose, they'd contribute to the soil's fertility, creating a self-sustaining cycle. But even with detoxification and organic matter, Martian soil would still need additional nutrients to support robust plant growth. This is where fertilizers come in. Tailored blends of nitrogen, phosphorus, and potassium, essential nutrients for plants, could be added to the soil, either imported from Earth or extracted from Martian resources. Some researchers have even suggested mining Martian rocks for minerals that could be processed into plant-friendly compounds. Of course, building fertile soil on Mars wouldn't happen overnight. It would require years of experimentation, adaptation, and patience, but the payoff would be monumental. The ability to grow food, produce oxygen, and create a sustainable ecosystem on another planet. It's a daunting task, but one that could ultimately bring us closer to making Mars not just habitable, but truly Earth-like. Now, let's think about what it would take to create a self-sustaining ecosystem on Mars. Water and oxygen are essential, but they're just the beginning. To truly transform Mars into an Earth-like planet, we'd need to establish a biosphere, a living, breathing system of plants, animals, and microorganisms that can support one another. This isn't just about planting a few trees or releasing a handful of microbes. It's about crafting an entire ecosystem from scratch, one that can survive and thrive in the harsh Martian environment. The first challenge is selecting the right organisms. Plants would play a crucial role, as they could produce oxygen through photosynthesis and help regulate the atmosphere. But not just any plants, they'd need to be genetically engineered or carefully chosen to withstand lower gravity, higher radiation levels, and thinner air. Imagine crops like hardy lichens or genetically modified algae, capable of surviving in extreme conditions while kickstarting the process of soil formation. But plants alone aren't enough. We'd also need to introduce microorganisms to break down organic matter and recycle nutrients, creating a cycle of life that mirrors Earth's ecosystems. And then there's the question of animals. Would we bring insects to pollinate plants, small mammals to help balance the ecosystem? Each addition would need to be carefully considered, as introducing the wrong species could throw the entire system out of balance. This brings us to a critical ethical dilemma. What if Mars already has its own microbial life hidden beneath the surface? Introducing Earth organisms could wipe out these native species, destroying a potential treasure trove of scientific knowledge. Even if Mars is lifeless, there's the risk of creating invasive species that could dominate the ecosystem, leading to unintended consequences. So, how do we design a biosphere that's both sustainable and ethical? One approach is to start small, with tightly controlled experiments in enclosed environments. These mini-biospheres could help us understand how different organisms interact in Martian conditions while minimizing the risk of contamination. Over time, as we learn more, we could gradually expand these ecosystems, always keeping a close eye on their impact. It's a delicate balance, but it's one we'll need to master if we're serious about making Mars a second home. The key lies in careful planning, rigorous testing, and a deep respect for the planet we're trying to transform. After all, terraforming isn't just about changing a planet. It's about creating a future where life, both earthly and potentially Martian, can flourish together. Imagine a symphony of machines and algorithms working in perfect harmony to transform a barren, lifeless world into a thriving, Earth-like paradise. That's the kind of coordination we're talking about when it comes to terraforming Mars, and artificial intelligence would be the conductor. AI's ability to process vast amounts of data, make real-time decisions, and adapt to unforeseen challenges makes it an indispensable tool for such an ambitious project. But let's break this down. What exactly would AI do, and how would it handle the complexities of reshaping an entire planet? First, AI would act as the brain behind monitoring and managing the Martian environment. Picture this: thousands of sensors scattered across the planet, constantly feeding data about temperature, atmospheric pressure, and soil composition. An AI system would analyze this information, detect patterns, and make adjustments to keep the terraforming process on track. For example, if a certain region isn't warming as quickly as expected, the AI could redirect heat-generating technologies or adjust the placement of reflective materials to boost the effect. This level of precision and adaptability would be impossible for human operators to achieve alone. Then there's the role of AI in controlling robotic construction crews. Building the infrastructure needed for terraforming, whether it's setting up solar mirrors, drilling for underground water, or constructing habitats, would require armies of robots working in unison. AI would be the one coordinating these machines, ensuring they operate efficiently and avoid conflicts. Think of it like a highly advanced traffic control system, but instead of managing cars, it's directing fleets of robots across the Martian landscape. And here's the kicker: these robots wouldn't just follow pre-programmed instructions. They'd learn and improve over time, optimizing their tasks based on what works best. But perhaps the most fascinating application of AI would be its ability to simulate and predict the outcomes of different terraforming strategies. Before we even attempt to make Mars habitable, we'd need to run countless simulations to understand the potential consequences of our actions. What happens if we release too much carbon dioxide into the atmosphere? How will altering the planet's magnetic field affect its climate? AI could model these scenarios with incredible accuracy, helping us avoid catastrophic mistakes and refine our approach. It's like having a crystal ball that shows us the future of Mars before we commit to it. Of course, relying on AI for such a monumental task comes with its own set of challenges. How advanced does this technology need to be to handle the complexities of planetary engineering? We're talking about systems that can process and analyze data on a scale we've never seen before, all while operating in an environment that's hostile to both humans and machines. And then there's the question of risk. What happens if the AI malfunctions or makes a critical error? The stakes are astronomically high, literally. A single mistake could set the entire project back decades or even make Mars uninhabitable for centuries. Despite these risks, the potential benefits of AI in terraforming are too significant to ignore. It's not just about making Mars livable, it's about doing so in a way that's efficient, sustainable, and adaptable to the unpredictable challenges of an alien world. And as AI technology continues to evolve, it's likely that we'll develop even more sophisticated systems capable of handling the intricacies of planetary engineering. So, while the road ahead is daunting, the possibilities are nothing short of revolutionary. So, how long would it take to turn Mars from a barren, dusty world into a lush, Earth-like planet? The answer might surprise you. Terraforming Mars isn't something we could achieve in a single lifetime, or even 100 lifetimes. Scientists and researchers estimate that the process could stretch anywhere from several hundred years to 1,000 years or more, depending on the technologies we develop and the challenges we face along the way. That's a timescale that's hard to wrap your head around, but it's a reality we'd have to confront if we're serious about making Mars habitable. One of the biggest hurdles is the sheer scale of the task. We're talking about altering an entire planet's atmosphere, temperature, and surface conditions. Even with advanced technology, these changes would take time to stabilize and become self-sustaining. For example, introducing greenhouse gases to warm the planet might take decades just to see measurable results, and creating a breathable atmosphere could take centuries. And that's not even considering the time needed to establish oceans, plant life, and ecosystems that could support human life. But here's an interesting question: who would oversee a project that spans generations? It's not like we can hand over a blueprint and expect future civilizations to stick to the plan. Would there be a global consortium of scientists, engineers, and policymakers dedicated to the cause? Or would it fall to private companies with long-term visions like SpaceX or others pioneering space exploration today? The logistics of maintaining focus and funding over such a vast timeline are almost as daunting as the science itself. And then there's the role of technology. Could we speed up the process with breakthroughs we haven't even imagined yet? Some experts believe that advancements in artificial intelligence, nanotechnology, or even genetic engineering could drastically reduce the time needed for terraforming. Imagine machines that can manufacture oxygen at an unprecedented rate, or microbes engineered to rapidly convert Martian soil into fertile ground. These ideas are still in their infancy, but they offer a glimpse of how innovation might one day accelerate the timeline. Of course, there's also the argument that patience is the key. Rushing a project of this magnitude could lead to mistakes or unintended consequences. After all, we're not just building a city, we're reshaping an entire planet. Taking the time to carefully study and test each step might be the wiser approach, even if it means waiting longer for results. Ultimately, the timeline for terraforming Mars is more than just a scientific challenge. It's a test of humanity's ability to think beyond our own lifetimes. It's about laying the groundwork for a future we may never see, but one that could transform the destiny of our species. And that's a vision worth pursuing, no matter how long it takes. So let's talk about the elephant in the room, or rather, in the solar system. Terraforming Mars isn't just a scientific challenge, it's a financial one. We're looking at a price tag that could easily reach into the trillions of dollars. Just think about it: building the infrastructure, transporting materials across millions of miles of space, and sustaining the effort over decades, if not centuries. The logistics alone are staggering, but here's the question: is it worth it? The potential benefits are hard to ignore. A second home for humanity could safeguard our species against existential threats like asteroid impacts or climate disasters. It could also open doors to groundbreaking scientific discoveries, from understanding alien ecosystems to advancing technologies we haven't even dreamed of yet. And let's not forget the symbolic value: a unified human effort to expand beyond Earth, to push the boundaries of what's possible. But who would foot the bill? Governments, private companies, or perhaps a global coalition? Each option comes with its own set of challenges. Governments might struggle to justify such massive spending to taxpayers, especially when there are pressing issues here on Earth. Private companies, while innovative, might prioritize profit over long-term sustainability. And a global coalition, well, that would require unprecedented levels of international cooperation. The cost isn't just financial either. It's also about resources. Every bit of material transported to Mars would need to be carefully allocated, every decision weighed against its potential impact. And yet, the rewards could be transformative, not just for those who make it to Mars, but for all of humanity. So, is it worth it? That depends on how much value we place on our future. If we see ourselves as a species destined to explore, to thrive, and to endure, then the cost might seem like a necessary investment. But if we focus solely on the challenges, the risks, and the price tag, we might never take that first step. The question isn't just whether we can afford to terraform Mars, it's whether we can afford not to. As we dive into the ambitious possibilities of transforming Mars, we must pause and ask ourselves, should we? Terraforming isn't just a technological challenge, it's an ethical crossroads. Imagine standing at the edge of a decision that could reshape an entire planet. Do we, as humans, have the moral authority to alter a world, even one that appears barren and lifeless? It's a question that forces us to confront our role as stewards or invaders of the cosmos. One of the most pressing concerns is the potential existence of life on Mars, even in its simplest forms. What if beneath the red, dusty surface lies microbial life, quietly surviving in extreme conditions? By terraforming, we could unintentionally wipe out an entire ecosystem before we even understand it. This isn't just about science, it's about respect for life in all its forms, no matter how small or seemingly insignificant. The idea of erasing something so profound raises questions about our own humility and the limits of our ambition. Then there's the question of equity. If we succeed in making Mars habitable, who gets to call it home? Would this new world become a refuge for the privileged few, or would it be a shared resource for all of humanity? The history of colonization on Earth reminds us how easily power imbalances can lead to exploitation and inequality. Terraforming Mars could either repeat those mistakes or offer a chance to do better, to create a model of fairness and cooperation on a planetary scale. These ethical dilemmas aren't just hypothetical, they're a mirror reflecting our values as a species. They challenge us to think beyond the technical how and focus on the moral why. What kind of future do we want to build, and what principles will guide us as we reach for the stars? Terraforming Mars isn't just about changing a planet, it's about defining who we are and what we stand for in the vast expanse of the universe. When it comes to terraforming Mars, the sheer scale of the challenge makes one thing abundantly clear. No single nation, organization, or even group of scientists can tackle it alone. This isn't just a scientific or engineering problem, it's a human one. To make Mars Earth-like, we'd need an unprecedented level of international collaboration, bringing together governments, private companies, and researchers from every corner of the globe. But let's be honest, history hasn't always been kind to large-scale cooperative efforts. From geopolitical rivalries to cultural differences, the road to unity is often paved with obstacles. So how do we move past these barriers to achieve something truly groundbreaking? One way to approach this is by looking at past successes like the International Space Station. The ISS stands as a testament to what humanity can achieve when countries set aside differences and work toward a shared vision. It's a project that involved the United States, Russia, Japan, Canada, and members of the European Space Agency, nations with vastly different political systems and priorities. Yet they managed to create something extraordinary. If we can replicate that spirit of cooperation on a much larger scale, terraforming Mars becomes less of a dream and more of a possibility. But let's not sugarcoat it. Collaboration on this level won't be easy. There are real challenges to consider, like competing national interests, funding disparities, and even differing views on how Mars should be transformed. Some might prioritize scientific research, while others could focus on economic opportunities or even colonization. Balancing these priorities will require open dialogue, compromise, and a shared commitment to the bigger picture. It's not just about building technology, it's about building trust. One potential solution is to establish a global framework, something like a Mars Terraforming Alliance, where every participating nation and organization has a voice. This alliance could set common goals, allocate resources fairly, and ensure that the benefits of this monumental effort are shared equitably. It would also provide a platform for resolving disputes and fostering mutual understanding. After all, terraforming Mars isn't just about altering a planet. It's about uniting humanity in a way we've never done before. And while political and cultural differences are significant hurdles, they're not insurmountable. History has shown us that when humanity faces a challenge that transcends borders, whether it's eradicating diseases or exploring the unknown, we're capable of coming together in extraordinary ways. Terraforming Mars could be the ultimate test of our ability to collaborate, innovate, and dream collectively. The question isn't whether we can do it, it's whether we're willing to rise above our differences and work together for a future that benefits us all. Terraforming Mars might give us the tools to survive, but what about the psychological challenges of actually living there? Imagine stepping onto a planet where the sky isn't blue, the air isn't fresh, and the horizon stretches endlessly in shades of rusty red. For future Martian colonists, the psychological impact of this alien environment could be as daunting as the physical challenges. Isolation would be a constant companion millions of miles away from Earth with no quick way back. The absence of familiar landscapes, the inability to feel the sun on your skin, and the reliance on artificial habitats for every breath could create a sense of detachment unlike anything we've experienced on Earth. To understand how this might feel, we can look at extreme environments on our own planet. Take Antarctica, for example. Scientists stationed there often face months of darkness, cramped living conditions, and the knowledge that they're cut off from the rest of the world. Studies show that these conditions can lead to feelings of loneliness, stress, and even depression. But here's the thing, Antarctica is still Earth. You can step outside, breathe the air, and see the stars. On Mars, even those simple comforts would be stripped away. So, how do we prepare for this? One approach is to design habitats that mimic Earth-like environments as much as possible. Think indoor green spaces, artificial sunlight, and even virtual reality systems that simulate the sights and sounds of home. Another key factor is community. Building strong social bonds among colonists will be crucial. Shared goals, regular communication, and activities that foster teamwork could help combat the sense of isolation. But let's not forget the lessons we've learned from space missions closer to home. Astronauts on the International Space Station often speak about the overview effect, a profound sense of connection to Earth when seen from afar. For Martian settlers, this connection might be harder to maintain, but fostering a sense of purpose and unity could help. After all, they'd be pioneers shaping the future of humanity. The psychological challenges of living on Mars are real, but they're not insurmountable. By combining technological innovation with a deep understanding of human psychology, we can create an environment where future colonists not only survive but thrive. The journey to Mars isn't just about building a new world, it's about ensuring that the people who live there can call it home. As we look to the stars and dream of transforming Mars into a second Earth, one question looms large: who should take the lead in this monumental endeavor? Companies like SpaceX and Blue Origin have already revolutionized space exploration, proving that private enterprises can achieve what was once thought impossible. But when it comes to terraforming an entire planet, the stakes are infinitely higher. Should this be a mission driven by governments with their focus on collective good, or by private companies with their agility and innovation? The answer isn't straightforward, and it opens up a fascinating discussion about the intersection of ambition, ethics, and responsibility. Private companies bring a unique edge to the table. Their ability to move quickly, take risks, and push boundaries has already accelerated our progress in space. SpaceX's reusable rockets, for example, have drastically reduced the cost of getting to orbit, making space exploration more accessible than ever. And Blue Origin's vision of millions of people living and working in space hints at a future where private enterprises could play a central role in shaping our off-world destiny. But terraforming Mars isn't just about technology, it's about reshaping an entire planet's environment. This raises critical questions about accountability. Who ensures that the methods used to warm the planet or create a breathable atmosphere are safe? Who decides how resources are allocated and who benefits from them? The profit motives of private companies add another layer of complexity. While innovation thrives in competitive environments, the pursuit of profit could lead to ethical dilemmas. For instance, if a company patents a key terraforming technology, could that create monopolies that limit access to essential resources? And what happens if the drive for efficiency or cost-cutting compromises the long-term sustainability of Mars as a habitable world? These concerns highlight the need for a framework that balances the ingenuity of private companies with the oversight and ethical grounding that governments can provide. At the same time, relying solely on governments might slow progress. Bureaucratic processes and shifting political priorities could delay critical advancements. The ideal scenario might be a hybrid approach where private companies lead the charge in developing groundbreaking technologies, while governments and international organizations establish guidelines to ensure fairness, safety, and sustainability. Collaborative efforts like these could harness the best of both worlds, the speed and creativity of the private sector, and the regulatory and ethical oversight of public institutions. As we ponder these questions, it's worth reflecting on what kind of future we want to build not just on Mars, but here on Earth as well. The choices we make about who leads the charge in terraforming will ripple across generations, shaping not only the red planet but also our values as a species. How we balance innovation with responsibility will define whether we create a future that's equitable and sustainable, or one that's driven by profit at the expense of the greater good. One of the most profound questions we face as we consider terraforming Mars isn't just about technology or resources, it's about life itself. What if Mars isn't the barren, lifeless world we imagine? What if, beneath its dusty surface or hidden in its ancient ice, we discover signs of Martian life? This isn't just a scientific curiosity, it's a game changer. Imagine the moment we find microbial life, even in its simplest form. Suddenly, Mars isn't just a planet to conquer, it's a planet to coexist with. This discovery would force us to rethink everything. If Martian life exists, does it have rights? Should we alter an entire planet's ecosystem if it means potentially harming its native inhabitants? These aren't hypotheticals, they're ethical dilemmas that could shape the future of humanity's relationship with the cosmos. On one hand, terraforming Mars could offer a new home for humanity, a chance to ensure our survival as a species. But on the other hand, could we justify reshaping a world that already harbors life, no matter how small or primitive? The implications go beyond science and ethics, they touch on our very identity. If we find life on Mars, it would be the first time we've ever encountered extraterrestrial biology. That moment would redefine what it means to be human, challenging our assumptions about life's uniqueness and our place in the universe. It's a humbling thought. We might not be alone, and we might not be the only ones with a claim to the stars. So, what happens next? Do we press forward with terraforming, prioritizing our survival over the potential risks to Martian life? Or do we step back, preserving Mars as a sanctuary for its native inhabitants, even if it means sacrificing our dreams of a second home? There's no easy answer, but one thing is certain: this question will shape not just the future of Mars, but the future of humanity itself. When we think about terraforming Mars, one of the most exciting possibilities lies in the role of robotics. Imagine a fleet of advanced machines working tirelessly across the Martian landscape, laying the groundwork for a future human presence. These robots could handle everything from constructing the first habitats to mining essential resources like water and minerals. The beauty of this approach is that it allows us to start transforming Mars long before humans ever arrive, making the planet safer and more hospitable for our eventual colonization. But here's the question: just how advanced do these robots need to be? We're not talking about simple machines that follow pre-programmed instructions. Terraforming Mars would require robots with a high degree of autonomy, capable of adapting to unpredictable conditions and solving problems on the fly. For example, they'd need to navigate rough terrain, repair themselves if something goes wrong, and even make decisions about where and how to gather resources. This level of sophistication is still a work in progress, but advancements in artificial intelligence and machine learning are bringing us closer every day. Of course, relying on robots isn't without its challenges. Mars is an unforgiving environment with extreme temperatures, dust storms, and low gravity that could wreak havoc on even the most durable machines. Robots would also need to operate for years, if not decades, without constant human oversight. That means they'd have to be incredibly reliable, with built-in redundancies to ensure they can keep functioning even if parts of them fail. And let's not forget the sheer scale of the task. Terraforming an entire planet would require thousands, if not millions, of robots working in concert. Coordinating such a massive effort would be a monumental feat of engineering and logistics. Still, the potential benefits are immense. By using robots to handle the initial heavy lifting, we could significantly reduce the risks to human explorers and settlers. These machines could pave the way for a smoother transition, creating the infrastructure needed to support life on Mars long before humans arrive. It's a vision that combines cutting-edge technology with bold ambition, and it just might be the key to making Mars a second home for humanity. Imagine a future where the same technology that transforms the barren, red plains of Mars into a habitable paradise also helps us heal our own planet. The journey to terraform Mars isn't just about creating a new home for humanity. It's about unlocking solutions to some of Earth's most urgent problems. Climate engineering, sustainable resource management, and advanced agricultural techniques developed for Mars could become game changers here on Earth. Take climate engineering, for example. On Mars, we'd need to thicken the atmosphere and regulate temperatures to make the planet livable. The tools and methods we refine for that process, like capturing and recycling carbon dioxide or creating artificial greenhouse effects, could be adapted to combat climate change on Earth. Imagine using Martian-inspired technology to stabilize our own atmosphere, reducing the severity of extreme weather events and slowing the rise of global temperatures. Then there's sustainable agriculture. Mars would require completely closed-loop farming systems where every drop of water and every nutrient is recycled with precision. These systems could revolutionize how we grow food on Earth, especially in areas facing water scarcity or soil degradation. By learning to cultivate crops in the harshest conditions imaginable, we might discover ways to feed billions more people without further straining our planet's resources. But here's the key question: how do we ensure that these innovations benefit both worlds? The answer lies in collaboration. Scientists, engineers, and policymakers must work together to share knowledge and apply Martian technologies to Earth's challenges. By viewing Mars not just as a distant goal but as a testing ground for sustainable solutions, we can create a future where both planets thrive. This isn't just about survival, it's about progress. The lessons we learn from terraforming Mars could spark a new era of innovation, one where humanity becomes better at preserving and restoring the environments we call home. And as we look to the stars, we might just find the tools we need to fix what's broken right here on Earth. The dream of terraforming Mars didn't just appear overnight. It's been a vision carried forward by some of the most brilliant minds of our time. Think about Carl Sagan, the legendary astronomer who, decades ago, first proposed the idea of making Mars habitable. He imagined a world where we could melt the polar ice caps, releasing carbon dioxide to thicken the atmosphere and warm the planet. Sagan's work laid the groundwork for everything we're exploring today, but he wasn't alone. Over the years, a growing community of scientists, engineers, and entrepreneurs have picked up the torch, each adding their own unique contributions to the mission. One of the most prominent figures in this modern era is Elon Musk, the founder of SpaceX. Musk isn't just talking about Mars, he's actively working to get us there. His vision is bold, establishing a self-sustaining colony on Mars within our lifetimes. SpaceX's Starship, a fully reusable spacecraft designed for deep space missions, is a cornerstone of this ambition. Musk envisions a future where thousands of ships carry people and supplies to Mars, kickstarting the process of turning it into a second home for humanity. But it's not just about the technology. Musk often emphasizes the importance of making life multiplanetary as a safeguard for our species. It's a grand vision, and one that's inspiring a new generation of space enthusiasts. Then there's Dr. Robert Zubrin, a rocket scientist and founder of the Mars Society. Zubrin has been a vocal advocate for Mars exploration for decades, co-authoring the groundbreaking Mars Direct plan in the 1990s. This plan outlined a practical, cost-effective strategy for sending humans to Mars and beginning the process of terraforming. Zubrin's ideas have influenced NASA and private space companies alike, proving that the dream of Mars isn't just science fiction, it's a tangible goal within our reach. But it's not just individuals driving this vision forward. Organizations like NASA and the European Space Agency are also key players. NASA's Perseverance rover is currently exploring Mars, collecting data that could help us understand how to make the planet more Earth-like. Meanwhile, scientists like Dr. Chris McKay, a planetary scientist at NASA Ames Research Center, are studying the possibilities of introducing microbial life to Mars as a first step toward transforming its environment. These efforts show that the dream of terraforming is a collaborative one, bringing together some of the brightest minds across the globe. What's fascinating is how these visionaries are approaching the challenge from different angles. Some focus on the technical hurdles, like developing the rockets and habitats needed to get us there. Others are looking at the biological and environmental aspects, exploring how we might alter Mars' atmosphere or introduce life to its surface. Together, they're painting a picture of a future where Mars isn't just a distant red dot in the sky, it's a vibrant, livable world. And while the road ahead is long and filled with challenges, the passion and ingenuity of these pioneers remind us that the dream of terraforming Mars is closer than ever. Imagine a future where humanity isn't confined to a single planet, where the lessons we've learned on Earth, both the triumphs and the mistakes, inform a new chapter of existence among the stars. This is the promise of terraforming Mars. It's not just about finding a new place to live, it's about redefining what it means to be human. As we grapple with challenges like climate change, dwindling resources, and a growing global population, Mars represents more than an escape. It's a blank canvas, a chance to build a society from the ground up with sustainability, innovation, and resilience at its core. But let's pause for a moment and ask ourselves, what does it truly mean to carry humanity to another world? It's not just about transporting people or technology. It's about bringing the essence of who we are, our creativity, our compassion, our ability to adapt and thrive. Mars could become a testing ground for new ideas, a place where we experiment with ways to live in harmony with our environment rather than exploiting it. Think about it. If we can transform a barren, lifeless planet into a thriving ecosystem, what could that teach us about restoring and preserving our own? Yet, this journey isn't without its challenges. Beyond the technical hurdles of terraforming, there's the deeper question of how we ensure that the best of humanity makes the leap to Mars. How do we avoid repeating the same mistakes that have brought us to the brink on Earth? The answer lies in intentionality, in building systems of governance, economics, and culture that prioritize equity, collaboration, and long-term thinking. Mars could be a place where we shed the divisions that have held us back and embrace a shared vision for the future. And then there's the question of identity. If humanity becomes a multi-planetary species, how will that shape how we see ourselves? Will we still feel connected to Earth, or will we begin to see ourselves as something new, citizens of the cosmos? These are profound questions, and they remind us that terraforming Mars isn't just a scientific endeavor, it's a deeply human one. It's about creating a legacy that transcends generations, a story of resilience and hope that inspires us to reach higher, dream bigger, and strive for a future where humanity thrives not just on Earth but among the stars. As we venture further into the dream of transforming Mars into an Earth-like haven, it's impossible to ignore the challenges that lie ahead. Terraforming isn't just a matter of flipping a cosmic switch. It's a delicate, high-stakes experiment with countless variables that could go wrong. Imagine for a moment what might happen if our attempts to warm the planet spiral out of control. What if the very technologies designed to melt polar ice caps and release carbon dioxide end up creating a runaway greenhouse effect, turning Mars into an uninhabitable furnace? It's a scenario that forces us to confront the fine line between ambition and recklessness. Then there's the question of introducing Earth life to Mars. While it might seem like a logical step to jumpstart an ecosystem, the consequences could be unpredictable. What if Earth microbes outcompete any potential native Martian life, wiping it out before we even discover it? Or worse, what if these organisms mutate in unexpected ways, creating unforeseen ecological imbalances? These aren't just hypotheticals, they're real risks that could derail the entire terraforming process. And let's not forget the sheer scale of the technical challenges. Building the infrastructure to transport materials, generate energy, and sustain human life on Mars is already a monumental task. But what happens if key systems fail? A single malfunction in a greenhouse gas generator or a water extraction system could set the project back decades or even render it impossible. These challenges aren't meant to discourage us, but to remind us of the importance of careful planning and ethical responsibility. Terraforming Mars isn't just about what we can do, it's about what we should do. As we move forward, we'll need to balance our ambition with a deep respect for the risks involved, ensuring that every step we take is guided by science, foresight, and a commitment to sustainability. After all, the ultimate goal isn't just to create a new home for humanity. It's to do so in a way that preserves the integrity of the universe we're trying to explore. Terraforming Mars is without a doubt one of the most ambitious and transformative projects humanity has ever dared to dream of. It's not just about reshaping a barren, dusty world into a vibrant, habitable one. It's about redefining our place in the universe. The challenges are monumental, from the thin atmosphere and freezing temperatures to the lack of liquid water and the constant bombardment of radiation. But the potential rewards, they're nothing short of extraordinary. Imagine a second home for humanity, a place where we can thrive, innovate, and ensure the survival of our species. Picture the scientific breakthroughs that could emerge from such an endeavor, advancements in technology, biology, and planetary science that could benefit life on Earth and beyond. Yet, as we stand on the brink of this audacious vision, we're faced with a question that goes beyond the technical hurdles. It's not just about whether we can terraform Mars, but whether we should. What responsibilities come with reshaping an entire planet? How do we balance our drive for exploration with the ethical considerations of altering another world? These questions force us to look inward, to reflect on our values, our priorities, and our relationship with the cosmos. The journey to making Mars Earth-like isn't just about science or engineering, it's about understanding ourselves. It's about confronting our limitations, embracing our creativity, and daring to imagine a future that once seemed impossible. And while the path ahead is fraught with uncertainty, it's also brimming with opportunity. So, what role will you play in this incredible adventure? Whether you're a dreamer, a scientist, an engineer, or simply someone who looks up at the night sky in wonder, your voice matters. Together, let's keep dreaming, keep exploring, and keep pushing the boundaries of what's possible. The story of Mars isn't just being written by a handful of experts, it's being written by all of us. And the best part, the next chapter is still unwritten.